realized that the software was available, and you could download, you can install, and you can play with it. When did you actually get involved? Like, how was the journey in between? How can this thing be free versus getting involved in a community and participating and working with the people?
I think when you first learn about like open source, that is your initial membership because you can't teach other people. You can't contribute until you get initiated. And so when you open that first book, it's like that's when it starts. Now, what do you do with it? Because sometimes the simplest thing you can do is report a problem. I remember the first contribution I made was not code, it wasn't literature, it was monetary in nature. The FreeBSD team and the OpenBS team, they typically maintain these like we need hardware list. Like there's a like, hey, it will be nice if we had access to this Intel network card so we can test drivers. And so what you would do is you would go to this wish list and you would just buy the stuff and send it to them. And I think the first thing I sent to was someone named Theo Durat. I think he was over OpenBSD. I hope I have his name correct. And he had this list. And I'm sitting here like, this person is maintaining all this value for people like me. The least I could do is send him a few items off this list because if he gets them, then he just makes the operating system better. So that was like my first contribution. Like based on my skill set at the time, I had more, I don't want to say more money than skill, but that was kind of where I was. So I did what I could do. But then I remember I was working at a company called Pier One. They did web hosting. They're spin out a rack space. And I know you all are involved with the OpenStack project. And so you got this little company that had a different take on web hosting, fully automated. You go to a web browser, you click a few buttons, and then you would basically form this request that would configure the RAID controller, get your hard drive where it would set up. And then within an hour, you got this web server with an IP address. And so I joined this web hosting company and everything was pretty much open source. MySQL, maybe Plesk wasn't, but everything around it was. And you just had to know the whole stack. You could get a phone call and someone would say, hey, my website isn't working. You better know PHP. You better know MySQL. You better know the whole thing because you got about 10 minutes to diagnose, troubleshoot, and get a resolution before it's on to the next call. And I remember this is when I don't know if cloud was becoming a big thing, but virtualization definitely was coming a big thing. And so you had the likes of VMware, but I remember there was a project called Zen, and there was a white paper, Zen and the art of virtualization. And I remember reading it and coming to work and setting up a server running Zen. And I was showing the Pier One people, it's like, look, we're giving people all these physical servers, and we're bound by how much literal rack space we have and ping pipe and power. Once you exhaust that, that's it. But what if you could give people like a VPS? And Zen looks like a good way of doing that with some of the stuff Intel was doing with the VTX instructions, and you get hardware level of security. And I remember setting this thing up. And I think that was my second contribution because spreading knowledge of what's possible, I think it's like the other cornerstone. So I remember people crowding around my cubicle, and I just had this server. I went to the storage room where we keep some of the backup servers. I pulled it out, and those things sound like jet engines when you turn them on in an open. Like those 1Us, those fans are so small, they make so much noise. And I remember having this jet engine take off at the cubicle, and people are like, what the hell is this? What are you doing? And why are the lights dimming? Because you're drawing all of this power. And I mean, I was like, dude, I got this virtualization thing. You can just create servers without physical servers. And people's minds were blown. And so now just taking something I learned in the open source community and showing people that we could do this too as a company kind of started my journey on the sharing. And now I'll get to the contribution part. So we're about 5 years into kind of this W-2 employee type career. I'm bouncing around companies. Every time I learn something, it just makes me more attractive in the market. Literally, salary increases every single time. So now I'm addicted to this feedback loop and I'm studying everything. Anything I can get my hands on, I want to know how it works. And so I joined this company called TSYS, and they're doing financial services, high regulation, and you're not using open source unless it's being bought by Red Hat or IBM. Other than that, all bets are off.
Right.
And I remember I wanted to push the bar on Actually, Python was probably my first product. I was going to get to Puppet, but I'll come back to that one. That company's using lots of mainframe, and lots of people sit around and complain, oh, mainframe, we're dinosaurs, we're old. And something told me, like, you should go figure out why the mainframe exists. And I remember driving down with a couple of members of my team to Columbus, Georgia, and they were like, this is the mainframe. You can walk in it. There's a little bench in there, and you can sit down. And we were talking about reliability, and we were explaining to them how we were using like these Dell 1U servers and running Linux, and how we use Nagios for monitoring. They're like, what's Nagios? I was like, oh, we put these agents on there and they detect when the servers go down, and then we can fix them. He was like, servers go down? I was like, yeah, they go down all the time. You can run out of disk space. These cheap things, they burn out. There's all kind of things that happen. So when that happens, we have Nagios, and then we jump right on it. We're really good. And then one dude was just really getting at us. He was like, I can't believe you guys, how you even tolerate this? And then we were kind of feeling a little bad. And his buddy jumped in to like correct him. He's like, hey, our systems went down too before. He's like, oh, you're right. 12 years ago, we did have an outage. And we're sitting there like, it's getting worse. How reliable? And then you see the thing, redundant motherboards, CPUs,
Mission
ARM that
critical.
moves bad disk drives out of the way. We're like, we don't have nothing like that. And then we started talking about how data is processed on the mainframe. And this is when my eyes lit up. He's like, Kelsey, look, you guys are just not doing a bad job, but it's very naive. When you get a packet of data, you all take a credit card and you stuff it 8 bits per integer, and you just wasting memory. And that's why you guys are buying servers with all of this memory, and you're still slower at processing stuff than the mainframe. I was like, well, what makes it different? He's like, do you know what a nibble is? I'm like, what's a nibble? It's half a byte. You can express a lot of this stuff in a byte. Oh, you guys are using XML for what? You're literally wasting a bunch of characters in processing. Here's EBCDIC. Fixed length fields. If you start at byte 16 and you go over this number of bytes, that's the credit card number. And it's packed deeply, so packed decimal. And so I'm starting to learn this, and then I'm contributing libraries to our Python stack. Hey guys, if we're going to convert this stuff from COBOL to Python, we got to understand EBCDIC. We got to understand packed decimal. There's no way that we can just do this with XML. It's going to slow everything down. And the mainframe can't understand it,
And that was
right?
part of your gig, was actually doing porting from COBOL to
No,
Python. Is
I
that
was a Linux system administrator. That's the key. I was a Linux system administrator managing, the transition from mainframe to Linux. But when you realize that the OS isn't the problem, it's the process. A data file comes in, Control M schedule this on a machine. You have to parse the actual file. If your code doesn't understand EBCDIC and packed decimal, then you're like, oh, just send it to the mainframe. Why are people saying send it to the mainframe? It's just an array of bytes. And so, as a Linux system administrator, you step up and say, hey, can I try? And then you figure out why people keep trying to avoid processing this thing. So, say, you know what? I know a little bit of Python. Maybe I can try it. But then you have to go learn all these other things. And then you end up wearing another hat. That's the entrepreneur mindset.
hmm
Hey, we can pre process these files ahead of time. We're just going to have to write some libraries. And so that was like my first, we can build what we need. And so I created a packed decimal library. I created something that understood EBCDIC, and then you can import it in Python. And then we could start converting some of those COBOL jobs into Python. And they ran just fine, but you needed that step. So that's
Right.
kind of what I mean by just going above and beyond. So that wasn't the job I was hired for. It was just a thing of like, hey, the Linux servers are fully automated. We got Pixie Boot, Kickstart profiles. That's easy. I could just sit back and wait on Jira tickets, or I can get involved. And I think that's what a lot of the open source ethos is about, the transparency of seeing a problem and then taking software and doing what's necessary to solve the problem. And then you get bonus points when you choose to share the solution with other people. And so that to me is like the core of open source to me. How you apply it is how we get to all these fancy projects and such. And so those are my first contributions. And then Python had a bug. As I was packaging things up, I was like, Python eggs versus pip packages versus this. I'm like, what are we doing? This utils versus this didn't work with this version of Python. I was like, packaging, it's chaos in the Python community back in 2005, maybe. And I started contributing. I went upstream, was like, hey, I saw some Python proposals to improve packaging. The goal is to try to unify some of these things. Disutils to virtual vim. There was a tool called pip to manage these dependencies. And there was a lot of open issues. And I was like, you know what? If I jump in and help, we can use some of these features for what we're trying to do at work. So I kind of focused my contributions on speeding up the packaging process or some of the features so we could use them. And so that was my contributions back to the broader community. Um, and it was tricky because we couldn't really do open source at work. So you have to go home, contribute at nighttime, get it merged upstream. And then once it's merged upstream, then you can go back to work and just pull it in and be like, yeah, no open source work here. And so that was kind of the issue where it's really hard to do this kind of stuff when maybe your employer at the time isn't 100% on board.